Solving quadratics by factoring. Our objective is to use the zero product property, which we'll learn what that is in a minute, to solve quadratic equation in standard form with the leading coefficient of 1. We're going to stick to a leading coefficient of 1 right now. In other words, if you look at this example I did up here, it's x to the second plus bx plus c. If you notice my x to the second coefficient is 1. We're going to stick with that today because once you introduce a larger coefficient or a different leading coefficient, it complicates the problem a bit. Okay, so first of all, we know what it means to solve a quadratic. We did it in this last section. We solved quadratics. Again, quadratics are x squareds, right? The largest degree is x to the second. And we solved them. Like in this guy here, we solved this guy by finding what values of x will make this true. We found two different values, 1 and 5, and we found it by graphing. We graphed it. Okay. There are other methods to finding solutions besides graphing. Graphing does work sometimes when the solutions are nice whole numbers and you have access to a graphing tool. Okay. But we'll need other methods as we get into more complicated polynomials, and those solutions tend to be more not what I call not nice numbers like 5 and 10. They end up being like 1/3 or square root of 3. Okay, not nice numbers. So first we have to know, what does it mean to factor? So we have to know what the word factor means. A factor is what we call a number that we multiply. So if I'm multiplying 2 times 3x, oh wait, let's just make it 2 times 3. If I'm multiplying 2 times 3 and that equals 6, the 2 and the 3 are what we call the factors. 2 and 3 are the factors, and 6 is what we call the product. Okay, so what does it mean to factor? Well, it means that we look for what do we multiply to get that thing. So if I asked you to factor the number 12, I'm looking for what numbers give me 12. So if I want you to factor 12, you could give me 1 times 12. That does technically work. This is like one of those bit of gray areas. We don't really like these factors because 1 is a factor of everything. So we don't tend to use 1. So we don't use 1 as a factor just because it's the factor of everything. So it's really boring. So we don't normally even list that one. But you could list me 2 and 6. Those are factors of 12. You could list me 3 and 4. 3 times 4. So those are all the factors of 12. So we're looking for, again, those factors of 12. Okay. So what multiplies to give me 12? So we're going to be factoring polynomials, but it's that same idea. What do I multiply? So if I'm asked to factor this guy, x squared plus bx, it's asking me what two things can I multiply? What things can I multiply to get this? Okay, and in this case, we're going to use an idea called the greatest common factor. We're going to use the greatest common factor and the distributive property. But we're going to use the distributive property backwards. Instead of multiplying in, we're multiplying out, or unmultiplying, dividing, I guess we could call it. Okay, so I look at, this has two terms. It has an x squared and a bx. Okay, so this has two terms. So there's my two terms, an x squared and a bx. It has two terms. But these terms have a factor in common because this first term is an x times an x. The second term is a b times an x. If you notice, they have an x in common. That is a common factor. So I can use the distributive property backwards and write the x out front. And now I ask myself, x times what gets me this first term? Well, x times x. So if I distribute this x in there, I'm going to get that x squared. Okay, and then my plus sign just comes from here. Here's my plus sign, plus. x times what gets me b times x? Well, times b. So now if I was to distribute this in, that gives me x squared. That gives me bx. That gets me back to here. But now I have this written as two factors. My two factors are x and x plus b. X plus b is the whole factor. That's one factor. So my two factors are x. Oh, sorry. My factors are x times x plus b. So one factor, two factor, there's my two factors, equals their product, which is x squared plus bx. So there's the product, because when I distribute that x in. Okay. So the very first step in what we call factoring or is looking for multiply is this greatest common factor idea. That's always our first step in factoring. Is we always want to be looking for that greatest common factor. That's our first step in factoring, is that greatest common factor idea. Okay. All right. So now here we have a developer wants to construct buildings on different sized square lots. So the lots are square. The city has a setback rule that requires buildings to be a minimum distance from the street, meaning you can't build the building on these 15 feet. Okay. The development company plans to use the entire area that is allowed to build on. Okay, so here's our buildable area all right here. There's our buildable area, and there's our setback zone. So here they give us some information here. The buildable area of a square lot is this idea, this x squared minus 15x, where x is the side length of the lot in feet. So if you notice, this is x, this is x. So first I want to make sense of this equation. Where did it come from? Where did the x squared come from? Okay. Well, this length is x and this length is x. So that's just the area of the entire lot. That x squared is the area of the lot, of the entire lot. Okay, but now where did this 15x come from? Well, 15 comes from this length is 15. But this length of the entire lot is x. So the area of this unbuildable is that 15. So this is the area of the, unbuildable space. Okay, so the area of the entire lot is x squared, but I can't build on that 15x square feet. So that's the area of the unbuildable space. So the area of the space here. So it's the area of this stuff. Let's make it pink. The area of this stuff all in here is 15x. But the area of the whole thing is x squared. Okay, so the two together is the buildable area, the area where I can build on. The entire lot minus the area of that unbuildable space. Hey, but this can now be factored. Because if you notice in this, they both have an x. So we're going to factor out that common factor. We're going to factor an x out. Now ask myself, x times what gets me x to the second? Well, x times x minus x times 15. So now if I distribute this in, I would get back to where I started. So there's my two factors, x and x minus 15. But now let's ask myself, where does the x and the x minus 15 show up? Well, again, the x is just the length of this space. So this x could be this x right here. And the x minus 15 would be this length from here to here is x minus 15, because the whole length is x, and then I'm backing off those 15 feet right there. So that length, so again, this still represents the buildable area. It's just written in a different way. Instead of me taking the area of the entire lot and taking off this unbuildable area, I'm just finding the area of the buildable space by taking the x times the x minus 15. Okay. All right, we're not really doing much else with that problem, but